A sequence is defined as a function whose domain is the set of positive integers. So the terms of a sequence will look like this. So here's the domain 1, 2, 3, all the way till n. So we'll call that our domain. And these numbers correspond to the actual terms. So first term we'll call A1, second term we'll call A2, third term is A3, all the way till the nth term, meaning the general final term. Okay. A1 is usually the first term. An is the nth term. The entire sequence is denoted as, let me write it. Let me see if am I zoomed in enough? Is that okay? Or I can't tell from my end.
The entire sequence is the A? Is what? The entire
is
sequence?
denoted
Okay.
as an from n equals 1 to infinity. So you have the name of the sequence will be a sub n. Okay. So example, the terms of the sequence a sub n is equal to 3 plus -1 to the n, where n starts at 1 and goes to infinity. And so that sequence would look like, or the the terms of it are going to be 3 plus a -1 plus, right? Sorry, it's not plus, that's a series. This is a sequence. So, comma, 3 plus a -1 squared, which would be positive, right? And then 3 plus -1 to the third, and it keeps on going forever. So that would simply be what? 2, 4, I think it just keeps repeating, right? Let's see here. Yeah, 2, 4, all the way till the nth term, which is 3 plus a -1 to the n. Okay. So that's the notation and the general idea. Okay. let's do another one. Let's call this the sequence B, I guess. Whatever. Let's find the terms of the sequence B sub n equal to n over 1 minus 2n, right? So we get used to the notation. That's simply going to be from 1 to infinity, right? It's going to be 1 over 1 minus 2, comma, 2 over 1 minus 2 times 2, 3 over 1 minus 2 times 3, and it just keeps on going all the way until the nth term, n over 1 minus 2n. Okay, so that would be 1 over negative 1, 2 over what? 1 minus 4, negative 3, right? 3 over 1 minus 6, negative 5, all the way till the nth term. Okay. And if you see no label, see how I did not write 1 to infinity right here? Then you should assume it's going to be 1 to infinity. Where 1 is the first term and n is the nth term. But that doesn't mean it's the final term. It just, this is the general form and it keeps on going. There's still n plus 1, n plus 2, etc. Hence the dots here. Okay. So now let's talk about definition of a sequence that converges. Okay, so that's just the basic notation. So now let's get into the theory. So this next part is a lot more what mathematics is about than the last couple of chapters. It's very theoretical stuff. The definition. One second. What did I write here? Okay. So the sequence a sub n from n to infinity converges to L if and only if if and only if given any number epsilon greater than 0, there exists an integer, capital N, for which a sub n minus L is less than epsilon for every n greater than capital N. If there is no such number L, then we say the sequence diverges. So in this entire section, you're going to be checking, you're going to be given a sequence and you're going to say, okay, does it diverge? And I know this definition is very wordy, but let's try to put it in plain English because I need you to know what this means. Sequences whose terms approach limiting values are said to converge. So this is in plain English. This is the mathematical definition. This is in plain English. Now to make it even more simple, what I'm saying is if a limit of a sequence exists and it converges to some number L, a finite number, where L is a real number, and it is the limit of an um, then an converges. So to keep it simple, if L exists, then the sequence converges. If L does not exist or is infinite slash negative infinity, right? Either way, the sequence diverges. So all these things are saying the same thing. So I'm not gonna, well, if this was a higher level math class, I'd make you use this to do proofs, but we're not gonna do that. What I need you to be able to do is find a limit, check if it's finite, and then tell me, does the sequence converge? Yes or no? If it doesn't, does it diverge? And you'll explain why. Because the limit did not exist or is infinite. So you'll say one of these things. But it's not too crazy once you start to see what they're saying. For example, find a limit of the sequence a sub n equals 1 plus 1 over n squared. Does this converge? Or what is the limit? Similar question, right? So the limit as an goes to infinity would be this, right? So I wrote the same thing again, sorry. Right, so we know if you take the limit of this goes to 0, right? So we end up with 1 squared, which is 1. Going
Why
back
we,
to Cal 1. What's
I'm
up?
sorry, why we cancel the square with the 1 over n?
Because the n will go to infinity, so this becomes infinitely small.
Okay.
So this part goes to 0. When you take
0, oh, okay.
the limit, this goes to 0.
Right.
Then this stays 1.
Okay. Got you.
So I'm left with this.
Thank you.
So it goes back to infinite limits in Cal 1. Right? So that's going to be very useful for checking these sequences. Okay. Let me give you the properties, see if I can fit them in here. Okay, so suppose that a sub n from n equals n to infinity. Let's call that n sub 0, I guess. And b sub n from n equals 0 to infinity. Let's suppose that both of these converge. Then the following is true. So number 1, the limit as n approaches infinity of a sum of sequences, sum or difference. I'm going to go ahead and combine these into one. Sum or difference. Oh shit, that could be it. Is equal to the limit of these separately. So just separate them and put your plus or minus. I'm trying to combine the formula. There was 2 of them. I think that's unnecessary. Number 2, the limit as n approaches infinity of a sub n times b sub n is equal to the limit of an as n approaches infinity times the limit as n approaches infinity of bn. So you can find the limit separately, and then just multiply. Okay. And the last one, the quotient. If you have a limit of a quotient, where the quotient is an over bn, you can separate them and take the limit separately. Assuming that the limit of bn is not 0. Okay. All right. All right. So let's do some examples, and now we will start checking, does that sequence converge or does it diverge, right? And on a test, I don't want you to just say 1A or, converge or diverge. I want you to tell me why. That's what matters, right? Otherwise, it's just a flip of a coin, and that doesn't really make any sense. Okay. The first example here. Determine if the sequence converges or diverges. So I'm going to use the same one from earlier, and let's see if it makes sense. I remember how we found that pattern, right? It was going to be 2, 4, 2, 4, forever. Does this converge?
No.
No, right? Because if you take the limit and n approaches infinity of a sub n, it's going to be non-existent because it does not stop at a specific value. There is no limit. So going by the definition, we say if the limit does not exist, therefore A sub n diverges, right? Yeah. So that's what I want you to say there in plain English, right? Since you would say, since the limit of an does not exist, then A sub n diverges. That's how you would answer that kind of test.
So this one diverge.
Yeah.
Okay.
Since the limit does not exist, the sequence A sub n diverges. So this would be like your answer. Okay. You got any questions on this first one?
No.
Okay, let's do another one. Determine if the sequence converges or diverges. So let's do the same one from earlier. Where we had B sub n equal to n over 1 minus 2 to the n, right? And that was, we wrote out a few values, and we got -1, right? -2/3, -3/5. There's a couple, like two pages ago. So the question is, does this converge? I'm like, maybe, right? The way you check is you take the limit of B sub n as n approaches infinity. So you take the limit of n over 1 minus 2n as n goes to infinity. So what is this limit? This is a Cal 1 question, right? Do you remember?
Can you remind us what is this?
The limit is n goes to infinity.
Yeah, remember if when you're doing an infinite limit, right? Look at the degree at the top and bottom. So you see how this is degree 1, this is degree 1, right? When they are the same, you take the coefficient of the highest power. So you're gonna write the coefficient of the top is a 1, right?
Yes.
Coefficient of the highest power in the bottom is a -2. So this converges to -2, or rather, I should say, the limit is a finite number, -12. Therefore,
Yeah, I remember.
Bn converges. So you would say, since the limit exists and is finite, then, or therefore, right, B sub n converges. Any questions on this one? All right, let's do another one. Then we'll move on to something, a new idea, but still the same stuff. Let's see here. Determine if the sequence diverges or converges. A sub n is equal to n squared plus 1 over 2n minus. So you take the limit of a sub n as n goes to infinity, which will be the limit as n goes to infinity of n squared plus 1 over 2n minus 3. What is this limit?
Is it 1 over 2?
Well, what is the highest?
You
What is,
divide into it, right?
depends. You could do the division, but if the power on top is bigger, that means the top will grow faster, right?
Yes.
So it's going to be infinity automatically. So you don't have to do any work because the top will grow much faster. On the previous one, the degrees were the same. So you just take the number, or you could do the division, and then you would get the same thing. But here we don't really have to. If you see that the top is bigger, it's going to be infinite. If you see that the bottom is bigger, degree, it's going to be 0. If it's equal, you have to do this. Right? Those are the ideas from infinite limits in Cal 1.
Yeah. Okay, got you.
So since the limit of a sub n is infinite, then the sequence diverges. So on all the questions in 9.1, all you have to do is take the limit and check. Okay. Well, for most of them, I forgot there's one that you can't do that. All right. Let me write this on you. Another theorem called the squeeze theorem or the sandwich theorem, depending on what book you're reading. Assuming you read lots of math books, right? Squeeze. All right, so this is the idea. I'm gonna give you the math theory and then I'm gonna try to break it down for you so it makes sense in English, right? So suppose A sub n and B sub n are convergent. So you know that an and bn converge to something. You already know this. Convergent sequences. Both converging to the limit L. Okay, I should probably write some notation here. Let's say n is equal to n sub 0, n goes to infinity. Same thing here, n starts at some initial 0 and goes all the way to infinity. Okay, if there is an integer n1 greater than n sub 0, such that for all n greater than or equal to n1, and the following, a sub n, is less than or equal to c sub n, which is less than or equal to b sub n, then that means that c sub n also converges to L.
In the middle, C of n, A of n less than or equal C of n.
Yeah, c sub
Okay.
n down here. Mhm.
Okay.
Okay. So basically what I'm saying is if you know AN and BN converge to L and CN is in the middle, then CN also converges to L automatically. That's what the squeeze theorem is telling you.
Excuse me for I have hard
Mhm.
time reading. So then you open like a set and say L3. The last part that you couldn't read it. Yeah, this last to the right.
Right here.
Yes. What is this? I couldn't read the whole set.
N is equal to N sub 0 to the infinity. So it's the same notation as this. N equals N0 to infinity. N0 being, so basically I'm saying the sequence starts at some initial number, goes to infinity, and they all start at a similar number.
Oh yeah. Okay, I got you now.
Mhm.
Sorry about that.
Oh, that's okay. I think I was writing too small anyway. Okay. Alrighty, let's see if I can find an example. Here's a corollary from that. So if the limit of n going to infinity of the absolute value of the sequence a sub n is equal to 0, then the non-absolute value also converges to 0. That's just a side note. Okay. Let me see if I can find a good example for you. Here's a, oh, yeah, let's use this example. It's an easy one. Okay. So we know that the Triggs function sign is going to be between -1 and 1, right? Do you agree with that?
Yes, from the property of sines and cosine.
Yeah, it's never bigger than this. Now, if I divide everything by n, assuming n is greater, let's assume is not negative, right? Actually, I don't think it'll matter. Let's forget that. Now, we know that if I call a sub n equal to -1 over n, and b sub n equal to +1 over n, we know that both of these limits, right, is going to be 0, correct? Do you agree with that?
Yes.
So that means if the limits, if I take the limit of all three pieces, right, then that means that the limit of the middle one, even though I don't know what it is trapped between 0. So I'm going to squeeze this, meaning this limit has to be 0. That is what the theorem is trying to tell you. Does that make sense?
Yeah.
I should probably use, let's use x's. Well, I already put n's everywhere. Let's change the sign to sign x to sign n, because I shouldn't have two variables. So I just made up this example right now, so forgive me. So that means that this limit of sine n over n as n approaches infinity is equal to 0 because of the squeeze theorem. So you're basically squeezing that limit in the middle, forcing it to find the limit you want. So the ones outside are easy to find, but the one inside may not be because sine n keeps cycling forever, right? It's a periodic function, correct? So we're like, does it go to 0 or does it not? We can't know for sure, so we apply the squeeze theorem to prove it. So now I know for sure. There's no doubt. Is there any questions about what the squeeze theorem is telling you?
No.
All right. Okay, let's move on then. More definitions. The sequence a sub n, if n equals 1 to infinity, is considered to be increasing if each subsequent term is bigger than the first is bigger. So basically it keeps growing, right? Or the first one is smaller than the next one, which is smaller than the third one, etc. All the way till a sub n or a sub n plus 1 forever. Okay, so that's the definition of a sequence increasing, and that's how you would check or show it. Okay. That's number 1. Number 2, the sequence of a sub n, n equals 1 to infinity, is decreasing if a1 is greater than or equal to a2, is greater than or equal to an greater than or equal to an plus 1, etc. If a sequence is increasing or decreasing, it is called monotonic. Now, it needs to be decreasing or increasing for all n till infinity. Otherwise, it is not monotonic. Meaning, if it's decreasing for the first 1,000 terms and then all of a sudden it's not, or the first 1,000,000 terms and then it stops increasing or decreasing, then you would say it is not monotonic. You would say that it is bounded. There's another definition. What is bounded? So we say that the sequence a sub n from n equals n sub 0, just some general term. We say that this is bounded if there is a number capital M greater than 0 called a bound. For which a sub n is less than or equal to capital M for all n. So basically, there's this upper bound that it will never surpass. So it looks like it's decreasing, and then it suddenly gets to this point, and it just stops. It can't pass it. So the next couple of examples are going to check. Is this sequence monotonic, or does there exist a bound where it stops? Determine whether each sequence is monotonic. So part A, I guess. Least capital because I've been using little a for sequences. B sub n is going to be 2n over 1 plus n. Ouch. Is this monotonic? And so we got to check. It looks like it's monotonic. Because if we take the first few terms, right?
Because it's increasing, right?
It looks like it is increasing because if I plug in
4,
one,
for example.
let's plug in a couple, right? Let's do 1 and then 3 and then 4. 2, 3, 4. So 2 times 1 over 1 plus, so 2, right? So the next one will be 2 times 2 is 4 over 3, right? Next one will be 6 over 3 plus 1, which is 4. Next one would be 1, 2, 3, 4. That would be 8 over 5. If I simplify this, that would be 4 by 1. This would be what? 4/3. It doesn't change. This one will be 3/2, right? Is this increasing?
Yes.
Yeah, it is, right? But do we know for sure that it's going to stay that way for the next billion terms? There's no way to, we can't just keep writing it forever, right? So what we're going to do is check for a general n plus 1. So we're going to say, all right, here's the nth term. Is it true that this is less than or equal to 2 times n plus 1? In general, is this still true? Do you see what I'm doing?
You substituted for n by n plus 1.
Yeah, so I'm looking at the nth term and I want to see, is it still true? Is it still increasing for the n plus 1 term, meaning the next term beyond n, right? Let's find out. Let's check. So we do some algebra, right? Let's put some arrows here. This would be 2n over 1 plus n. Distribute, that would be 2n plus 2 over n plus 2, correct? Okay. Now, if I were to get rid of these fractions, I could say that this is 2n times n plus 2 less than or equal to 2n plus 2 times 1 plus n, right? If I do a cross multiplication, right? Or just cancel the fraction, however you want to think about it. If I FOIL all this nonsense, is 2n squared plus 4n less than or equal to 2n squared plus, let me see, 2n plus 2n plus 2 plus 2n. Let me double check I did that right. 2n, 2 squared, 2. Yeah, that's good. Is this true?
Yes, it's increasing.
Is this one smaller than this one?
Yeah, the first part equal to the second part, but the second part had plus 2 extra. So it always would be plus 2, always would be bigger, right?
So we showed it, right? That with general terms, it is still true. So therefore, B sub n is monotonic. Because it is increasing. And we showed that here. This showed it there. Does that make sense?
Yes.
Okay. It's kind of like an informal proof, I guess. We're not going to get too formal because it's already getting, you know, pretty mathy, I guess. We're getting close to real math, so I don't want to get too close to that. All right, let's do another one. Part B. Oops, my pen ran out. No, still good. Okay. C sub n is equal to n squared over 2 to the n minus 1. Same question, part B. Is this monotonic? So it helps to do a few terms, right? To see what the hell's going on. First few terms will be, for 1, we get 1 over 2 minus 1 is 1, right? Second one, we get 4 over 4 minus 1 is 3. Okay. Still true. Next one, 3 would be 9 over 2 to the 3 is 8 minus 1 is 7. Next one will be 4 squared, which will be 16 over 2 to the 4 is what? 16 minus 1, 15. Are these still increasing?
It's decreasing.
Yeah, if we're going this way, what happens? What happens from here to here?
It decreases.
Now,
Oh, it
4/3,
increase. No,
this
it
one,
increase.
this one increased, right? But then here to
Increase, yes.
here, right? If the fractions bother you, we could change it to decimals if you want.
It's increasing less.
So this is really 1, right? This is really 1.333 forever. This is really 1.285, whatever. And then the last one is 1.0666. So from here to here, increase. From here to there, decrease. From here to here, decrease again. So it does not follow the definition that we said A1 is less than A2, less than A3, right?
Yeah.
So this is not monotonic by definition. We don't need to prove anything here because the first few values give it away. You see what I mean?
Again, one more time.
What's up?
We kind of got lost a little bit on the first. You said because the first two terms gave it away.
Yeah, this is not true right here.
Okay, I got you. All right, now I understand.
Yeah, so that this needs to be true forever, and it's not. As soon as you see it no longer true, you would say not monotonic. Okay. You could do the n+1 idea and try to prove it, but sometimes you can see it right away, but not all the time. And sometimes the algebra can be messy when you do the n+1 stuff. It doesn't mean you can't do it, but you just might not like it. All right, here's another theorem. every bounded sequence every bounded no, that's fine. Every bounded sequence, monotonic sequence. Oops. I don't like the way they phrased it. Let me change that. Every bounded monotonic sequence converges, guaranteed. So if you know it's decreasing and you know that it is bounded, you automatically know that it is convergent. So like if you can't take the limit, let's say the limit's too hard to find, but you notice that there's a bound above or below. Actually it should be above, sorry. There's a bound above, and you notice that it is decreasing, then you will say automatically it is convergent because of those two things. Okay. So for example, let's see, this one is good. Well, I guess we can take a small break. Kind of lost track of time there. I was having too much fun. It's 9:17. Let's get back to it at 9:27. Try to finish up 9.1.
Okay.
We're actually right at the end. One last example. Just noticed it. Oh well. Determine convergence or divergence. So an is equal to 2 to the n over n factorial from n equals 1 to infinity. All right. Let's do a few values so we know what's going on. So the first one will be 2 to the 1 over 1 factorial, which is 2, right? Next one will be 2 to the 2 over 2 factorial, 2 cubed over 3 factorial, 2 4 factorial, 2 to the 5th, 5 factorial, which is really just 2, 4 over that, 4 over 2. This would be 8 over 6. This would be 16 over 4. So this would be 2, right? 2 over 6. Yeah. All right, so it looks like it's bounded above by 2, and that's the biggest it's going to get. And then it keeps decreasing, so it is decreasing, and it's bounded above. So it appears to be decreasing for all n. And the sequence is bounded by 2. Therefore, a sub n converges. But we need to show that it actually decreases. We need to prove it, right? But it appears like this is true. All right, so let's do the n+1 idea, right? So actually, sorry. So, yeah. Sorry, I know, just makes sense here. The definition we wrote earlier. Double check myself. Oh yeah, sorry, that's why. You want to show that it's decreasing, that's what I said, not increasing. So we want to show that a sub n is smaller than or equal to a sub n plus 1. So that would be 2 to the n over n factorial. Is that greater than or equal to 2 to the n plus 1 over n plus 1 factorial? Right? And let's see, right now it's not clear, but it looks like this one's smaller, but let's prove it. Okay. So technically this would be 2 to the n of n factorial, and this would be 2 times 2 to the n. This would be n times n factorial. Do you agree with this? These are equal? See how?
Yeah, they're equal.
So then if I multiply both sides of n factorial, I would get rid of it. And I'd be left with 2 times 2 to the n over n. This already looks smaller, right? But I'm not 100% yet. Let's keep going. Now I can divide out 2 to the n. So on the next step, I can say, well, is a 1 greater than or equal to 2 over n? Oops, made a mistake here. Sorry. This should be 1 second. Let me fix this. Denominator. It should be n plus 1 times n factorial. So we would have n plus 1 here when I cancel it. N plus 1. So now multiply both sides by n plus 1, so I get n plus 1 greater than or equal to 2, right? N greater than or equal to 1. Is this a true statement? Right, what is n?
N starts at 1, doesn't it?
Yeah, n starts at 1 and it goes on forever, right? So this is a true
Yeah,
statement. Yeah. Therefore, if this is true, then the rest is true. So this shows, right, therefore, This part is now true. So I'm going to just start asterisk it. So therefore asterisk is proven, and a sub n, which is so that is the end of 9.1. There's a lot of ideas I need you to go over. Think about as soon as you finish your test. Have any questions on them? All right, we'll stop here then, and I'll see you Monday. Open your tests. Double check test 2. I think this question I have an issue with. If there is a problem, use points back.
Professor, I have a couple of questions regarding to the score. So earlier we did an extra credit, the one that required by the college, and you said that you're gonna give us 10 points. Is this appear already, or will it appear at the final, or like is it?
No,
there?
I have not added it. So it's without those points. So right now it only has the curve and the points for throwing out that one.
Yeah, okay. And if there is any, you know, I'm most likely I'm the only one who asking for this. Everybody else shy. So if there is any extra credit coming in the way, let us know. Like we can write about our struggle with calculus. Anything you ask for it, and we do it.
Yeah, maybe I can think of a math problem or something. I'll think about that.
Thank you.
Yeah. I'll let you know. For now, yeah, you still have those extra 10 points, so I will add those to the lowest test. Right now, I usually add it at the end because I do drop the lowest test and replace it with your final exam. So
Yes, do that. That's great.
I'd rather wait and see which one's the shittiest test. Right?
Yes, that's be perfect.